Okay, today we begin Unit 4, Lesson 18B. The first part of this unit is going to be pretty simple because the main focus is on exponents, and really that's the main theme for this entire unit. And specifically today will be more about some of the things you would have learned probably more in 6th grade than in 7th grade. But we have plenty of time to go nice and slowly through all of this stuff. So it should be, at least the first part of this unit should be really, really easy. All right. So a little bit of background knowledge. Once again, more so stuff from 6th grade. Exponential form, so if we have something like this, we read that as 3 to the 4th power, and this is the part where you've got a lot of things that you're supposed to be filling in. And there's the bell. The 3 is the base. We always refer to that as the base. And of course the 4, we refer to that as the exponent. And when we have some base to some exponent, and I know that all of you know this from 6th grade, the 3 to the 4th power means 3 times 3 times 3 times 3. And when we write it out like that, that's referred to as the extended product. You're going to see those two words a lot in probably the first 5 or 6 lessons from this unit. The idea of extended product means at least think of it as writing it out like that before you go straight to the answer. And I realize that this one's pretty easy. But regardless, we know that 3 to the 4th power is 81. Now, for the first 4 problems, I'm going to have you do those in just a second. We're rewriting them as extended products and then evaluating essentially what I just did right there. So I'll give you about a minute to do 1 through 4. Number 1, 5 to the 2nd power, of course, means 5 times 5 as an extended product. And when we evaluate that, that means simplify it, which is 25. Number 2, 2 to the 4th power as an extended product is 2 times 2 times 2 times 2, which of course is 16. I saw some of you in number 3 not put parentheses around the base, and if there are parentheses around the base in the original problem, you really should put parentheses around the base when you're writing it out as an extended product. And you will see in a couple of minutes why that really is very important. And a lot of times it has more to do with the sign of the answer. But we should get negative 27 when we evaluate that. And then number 4, negative 9 in parentheses to the 2nd power is, of course, negative 9 in parentheses times negative 9 in parentheses, which is positive 81. All right. So, exponents. Where are they used? Well, they're used in computer game physics, which when you guys were doing your block coding for when we did Flappy Bird and Minecraft and all of those things, a lot of those are used in that. pH and Richter measure scaling, like for earthquakes. Science, engineering, economics, accounting, finance, and many, many other disciplines. We're going to extend this after exponents to exponential growth, which is used a lot in the real world, and so is exponential decay. So those two ideas of exponential growth and exponential decay, that's where we're headed after our initial exponent lessons. All right, go ahead and do number 5. One of the reasons for writing out the extended products is so that when you're doing stuff in your head, you don't make common mistakes. And as I was walking around, especially in number 6, that's what I saw. This one, I don't think anybody missed this one. That means negative 2 times, or negative 2/5 times negative 2/5 as an extended product. And then when we evaluate that, that's 4 over 25. But I saw a couple of you in this one, you're just jumping straight to the answer. And it's not 9 over 49, by the way, because this time we're to the 3rd power. It's 27 over 343. So just be careful with what you're doing there, okay? All right, next. There are special words for to the 2nd power and to the 3rd power. I know all of you have heard those before. 7 to the 2nd power sometimes is referred to as 7 squared. And 5 to the third power is sometimes referred to as 5 cubed. And I know you do have some blank areas that you're supposed to be filling in here. And then once we get beyond third power, we usually just say to the fourth power, to the fifth power, and so on, okay? But it's okay to use squared for to the second power and cubed for to the third power. So, sometimes there's a question of, well, where did those two words come from? Well, they come from the idea of area and volume. If you have a square, all the sides are the same, and so this is a square that has sides of 5, and so that's where it comes from, 5 squared. And the same thing with a cube. If you're finding the volume of a cube means all the sides have the same length, or all the edges have the same length. And so this is a cube that is 5 on each side, and so that is a 5 cubed is how we would find the volume of that. So that's really where those ideas come from. 5 squared and 5 cubed. Where square is 2-dimensional, and of course a cube is 3-dimensional. And we have a few blank areas that we're supposed to be filling in here. So next, and when we were talking earlier about exponent problems where the base had parentheses around it, this next set of problems is why it is very important that if you see parentheses around the base, you should keep parentheses around the base. And I sometimes refer to these as special exponent problems. -4 to the third power is, of course, -64, but this is the reason why it is -64, because -4 to the third means -4 times 4 times 4. The exponent goes with the 4, not with the negative. And once again, we have more blank areas that we're supposed to be filling in here, and that's the reason why that is -64. Same logic tells us that -6, not in parentheses, to the second power means negative times the quantity of 6 times 6. 6 times 6 is 36. We change it to the opposite of it, and we get -36. So the thing that you should realize very quickly is that if we have what looks like a negative base and there aren't parentheses around that, the answer to that, when you evaluate it, will always be negative. But that's not necessarily true if there are parentheses around the negative base. For example, if you go back to number 3 and number 4, you see that number 3 had a negative answer, but number 4 had a positive answer. Here, both of these were negative, okay? So don't get this type of problem confused with problems like -4 in parentheses to the second power, okay? All right, everybody go ahead and do the next. How many of them are there? 4? Go ahead and do all 4 of them, please. Number 7, -5 without parentheses around the base to the second power means this as an extended product. And of course, when we evaluate that, we end up with -25. Number 8, we do have parentheses around the base. So when there are parentheses around the base, sometimes the answer is positive, sometimes it's negative. How will you always know if there are parentheses around a negative base that the answer will be positive? How would you know that it would be positive without doing anything? Think about it. Turn to your shoulder partner and talk about that really quickly. All right, so how do you determine? How do you determine?
If it has an even.
If what has? If what?
Oh, if the base has an even exponent.
So, okay, so if the exponent is even, right?
Yeah.
If the exponent is even and there are parentheses around a negative base, the answer will always be positive. But if it's odd, because we would have an odd number of negatives that we're multiplying together, the evaluation would be negative. However, problems like number 7, it doesn't matter what the exponent is, right? It'll always have a negative answer. So number 8 is 64, because we have -8 in parentheses times -8 in parentheses. Number 9 ends up looking like this when we write it as an extended product. And that leaves us with -729. And then number 10, as an extended product, looks like this. And -7 times -7 times -7 is -343. So pretty easy so far. Now multiplying things with the same base. If we think about this in terms of an extended product, 4 to the third times 4 to the second means 4 times 4 times 4, that comes from 4 to the third, times 4 times 4, coming from the 4 to the second power. And if we are supposed to write that as a base with a single exponent, that would tell us that we have 4 to the 5th power, because we have 5 4s that we are multiplying together. And I already know what's going to happen over these next 3 days. Some of you are going to be like, yeah, but can't I just do this with the exponent? I will not be mentioning any shortcuts as far as exponents go. If you've got that figured out, good for you. Do what you want to do. I just know from experience, as soon as I start throwing out shortcut here, shortcut here, shortcut here, then come time for a test, when I've done that in the past, some people start to get things mixed up. It's better if you figure it out on your own and utilize it on your own, okay? All right, and then if we have variables as a base, it works exactly the same way. If we have c to the second power times c to the fourth power times c, c to the second power is c times c. C to the fourth power, we have 4 c's we're multiplying together, and then we have that last c there, and all together we are multiplying together 7 c's. So as an extended product, that's what it looks like. But once again, we are multiplying 7 c's together, so that means we're simplifying that to c to the 7th power. Okay? Pretty easy. Everybody quickly do 11 through 16. Number 11 should be 2 to the 5th power. Number 12 should be 3 to the 3rd power. Remember that 3 is really 3 to the 1st power. Number 13, if the base is in parentheses, we should leave parentheses around the base. And 13, if you didn't put parentheses around the base and I asked you to evaluate it, you would get a different answer. Because it should be clear to you that if I made you evaluate number 13, you would end up with a positive answer. But if you didn't put parentheses around the base in the simplified version, like right there, you would get a negative answer. So it's very important that if you see parentheses around the base, that as a general rule, let's leave parentheses around the base in the simplification. Number 14 is x to the 11th power. Number 15 is 1/2 in parentheses to the 5th power. And then number 16, we can almost kind of think of it like gathering like terms. So we can kind of gather our x's together, which would give us x to the 7th, and then sort of gather our y's together, which is y to the 3rd. And so that would give us x to the 7th times y to the 3rd, or x to the 7th, y to the 3rd. Okay? All right, we got 3 more like that, and then we'll do the last thing for today. So go ahead and do the next 3 problems. All right, number 17, we have negative w in parentheses to the 11th power. Number 18 should be 1/4 in parentheses to the 9th power. And then number 19, a to the 8th times a is a to the 9th, and b to the 3rd times b to the 2nd is b to the 5th, and so that's what we end up with, a to the 9th, b to the 5th. Okay, last thing for today. Writing extended products in exponential form. If we have 4 negative 2's in parentheses that we are multiplying together in exponential form, and today part of it was about putting terminology to things, but that's the extended product. In exponential form, it would be negative 2 in parentheses to the 4th power. Obvious. The second one there, and we have blank spots I think we're supposed to be filling in right now. D times C times D times D times C times C times C. And that's the extended product in exponential form. And in some respects, it's not much different than those problems we were just doing. In exponential form, that would be c to the 4th, d to the 3rd. Now, one quick point here. Expressions should be written with variables in alphabetical order if we have more than one variable. Okay? The next one, negative 5 times a times z times z times a times a. That would be negative 5 a cubed z squared. And typically if we have a coefficient in there, the coefficient should be written in front. That's why the negative 5 is in front. The variable should follow the coefficient. And then 3 times x times y times negative 2 times x times 4, that should be positive 24x to the second y. And so in that one we had 3 different coefficients, and when that happens, we want to find the product of those. So negative 3 times negative 2 times 4 is positive 24. That's where that came from. So product of coefficients should always be simplified. Okay, so we were just putting some general rules to some easy ideas there. Any questions about any of those 4 ideas? All right, finish off the rest of the problems. Number 20 through 25, I'll give you about a minute and a half to do those, and then we'll compare with our shoulder partner. Okay, 7 times 7 times 7, of course, is 7 to the third power in exponential form. Number 21, negative 8, 4 of them in parentheses results in exponential form as negative 8 in parentheses to the fourth power. 22, that results as 4x squared y cubed. Now I know some of you are writing the little multiplication dot in between. That's fine, but just recognize that that means the same thing. You don't really need that multiplication dot. Number 23, this time we'll have to multiply the 2 coefficients together, but we should end up with negative 54a to the fourth b. 24, once again we'll have to multiply the 2 coefficients together. So that would be negative 9/5 c cubed w squared. Number 26, multiply the 2 coefficients together. That simplifies to 1/6 g to the second kw. Any questions? All right, we are finished for today.